Test, test. Yo, yo. Cool. Okay, seems to work. I guess I don't need this. All right. Okay, I guess let's start. So off camera, I was working on Entroka, and I did a few changes. I've already started cleaning up the code a little bit. So for example, here we have several strategies. So we don't have only the Boltzmann, but we also have linear and exponential. I believe I also did some changes somewhere else, but I also added TTL, like the most basic version of TTL right now. So we have different resolutions. In the future, we're gonna have absolute and relative, or none. Obviously, if you don't want TTL, you don't need to have TTL. So you can also just select none. And then if we look here, how we use it. So we just say, hey, create TTL with absolute resolution seconds. I want this to be the minimum input count, and this is the maximum. Sorry, I said minimum. I mean maximum input count and maximum total count of the units specified here. Maybe this should be called units, something like that. I think maybe it would make more sense. So it basically means we can specify the TTL to be this value, right? So when we input, which means we call put, so we call hashmap.put. In the TTL value, we can have this as our maximum value. So if it's seconds, we can just do seconds, and you can see it's 6 weeks, 6 days, blah, blah, blah. So that's our maximum value. So a little over a month, so like month and a half almost. And that's how much we can have when it comes to TTL. But obviously, because it's absolute, which means we take the epoch, right? The Unix epoch as the reference, which means obviously we can have more than the input in the total count of those seconds. So that's what this does. It's more of a draft, really, because the relative doesn't work. Actually, it works the same way as absolute. And I'm actually not sure if the none works. I'm really not sure. I also added all of these prints just to see how big everything is in the record, because actually I think most of the logic is gonna be here in the record. And maybe today we're gonna be moving a lot of stuff from config into a record, because well, there are a couple of reasons. I'm gonna talk about them later. Yeah, so basically when we run the test, at the beginning we see, okay, this is record. The whole record is 200 bits. The B here means bits. And then we can see how big in bits is each property or each field, right? So we can see that, oh, okay, so for example, key is nothing, right? Value is nothing. Value length is nothing, but total length is 8 bits. The data, which is pointer, is 64 bits. The temperature is 8. TTL in our case is 40, because that's all we need. And we have no padding. It aligns perfectly, right? If, however, I were to change, for example, key from dynamic to static, and we say padding internal and external is false. Also, I added these. I just put it underneath features. Maybe it shouldn't be called features, but what these two do is they enable or disable the assertion of key and value inside all the hash map methods, or most of them. So when we do get, put, and delete, there's always key, and in the case of put, there's value. And we do assert the length. If for some reason we don't want to do that, which means we trust our client to always send the proper length, we can just skip it, right? So that's why we have this. And also when it comes to total length, so total length, we can get total length if both key and value are dynamic, right? So here we saw that total length is 8. Again, if for whatever reason we don't want that, we can use key and value length, right? So here we don't have value length, even though value is dynamic and it can have dynamic length, because value length equals total length minus key length, right? So when we're actually accessing, we just say, hey, start from key length and give me all the way to the end, right? And we don't even specify the end. It just gets computed automatically when we try to get that slice. So that's like a tiny optimization. If for whatever reason you don't want that, you can just opt out, and that's what this does. I think because this is kind of a research version, right, of the library or of the product, just to validate some ideas, right? Just like here, these strategies. Maybe Boltzmann is not gonna be the best strategy, and that's why I made it easy to add multiple strategies and to test them, right? And compare them after that. Just like the padding, maybe we're gonna always add padding, or maybe never, or maybe only internal but never external. I don't know. And the same with features, right? I just want to be able to turn these things on and off and see if maybe it makes sense sometimes, or if it actually makes sense to keep them false or true all the time, right? And in that case, I would just bake it in and I would just get rid of those features. Of these like knobs, right? Of these like configs. Yeah, so probably right now there is more things you can change than there is going to be in the release version. Yeah. Okay, so that's just a high level of where we are right now. And it's also good to mention that all of these things in the config, they are used in comp time to include or not include the code, right? So literally if you, if you select Boltzmann, the linear and exponential code is literally not going to be in the binary, thanks to Zig's lazy compilation, and also thanks to obviously us doing comp time condition to either use Boltzmann or exponential or linear. Yeah, so basically all of these fields in the config, they translate into some form of a comp time condition, which includes or doesn't include the code, right? Which means it's pretty hard to test because there can be so many different combinations of these that it's actually pretty impossible to test all of them. And that's why we're not even trying to set up any comprehensive tests right now. And we just test like the most basic functionality, and we don't even use expect, right? We're just trying to move fast, so we're just printing the stuff, and that's it. And the same applies to the sizes here. You know, I could have like a validation function for all of them, or something like that, but right now it just doesn't make sense. Yeah, so yeah, that's where we are. Now, the main issue right now is actually not with the hash map itself, which is arguably the most important part. Here, I think the init function, pretty simple. Dinit, pretty simple. By the way, here we have the comp time condition. So if a key is dynamic or value is dynamic, then we actually include this code in the binary. If both are false, then we literally don't include this code in the binary. The put, again, pretty easy. We assert the key length, value length, and then we just check a few things, and we just try to create a new record. We free, or we try to free whatever was there before, and we just put the new thing in the place of the old one, and we return nothing, or we return an error which says slot unavailable. Get, again, very simple. We just assert this, we assert that it's not empty, that it's not expired, and then we just assert that it actually is the same thing. If it's lucky, we increase the temperature for this record, and we decrease temperature for its sibling. Yeah, and then we just copy over the value into the buffer, and we return the slice or no match. And we delete, again, we just assert the length. We check if it's not empty and if it's actually the same thing, and we try to free, and we set it to default, and we return otherwise not found. And clear literally just clears stuff. So this is pretty simple, and I don't think we can really simplify this more. Actually, I'd like to maybe even add like more error handling or something like that. But right now there's kind of, what would I call this, like a dissonance between record and config. So for example, here we have config dot something, and that's always the type, right? But if, oh, and I already moved this, right? But before, like 2 days ago, here we actually called self.key dot value type, you know, and the same for the length type. We also called self.key dot length type. Yeah. Right now I started moving stuff into the record. Not random, record, right? So ideally all of this should probably live either in record or right inside config, but never inside the subfields of config, you know, and that's sometime a problem. So for example, here we have config.key.max size, you know, and it's not very clear, like, where should I get the max size? Like, do I get it from the config or do I get it from the record? You know, and even though I'm the person who wrote this code, even myself, I'm sometimes struggling. For example, here, if we want to get key length, so for max size, right, we go config.key, but for key length, we actually say record.key length, inside of which we actually call the max size, which is confusing, you know, it's confusing. Yeah, so and I think that even if I move all of the code inside just the root of the config, it's still kind of gonna be confusing a little bit. Yeah, So probably only the stuff that requires the self, which in this case is record. So all the methods that require record should be inside record, right? Anything else should probably be in the root of config. Yeah, I think that's how it should be, because right now, as you can see, the record is kind of big, right? And actually, I think maybe we're gonna have the same problem here, because already, as you can see, config is probably even bigger than record right now, even though we have a lot of logic hidden inside of these other structs, right? So for example, in data, this is the biggest one, I think. We have like min size, max size, diff size, assert size. Then we have these types. We have create value, default value, create length, default length. Yeah. Heading, there's nothing. Hash, very simple features, nothing. In strategy, we have these different strategies. Again, not sure what to do about that, because ideally I'd like to have it in the config, but at the same time I put it here because it kind of feels better. Yeah, so not sure. Yeah, but sometimes, for example, when we want to create the default value or create the value like itself, right, which we do inside the default or create record function. So here we say, like for empty, for example, we say config create empty, right? But for key and key length, we say config.key create value. We do the same for value, we do the same for temperature, right? So this is confusing. So I guess the first thing we can do is to move these create and default methods right inside the config. I think we should do that. And at least then it's gonna be a little bit easier, because also, I don't know if you've noticed, but here we have key and key length, right? Both use config.key. Then we have value, which uses config.value, but value length, as opposed to key length, it doesn't use config.value, right? It uses create value length, because to figure out value length, we have to look at the whole config, which we cannot do inside value, right? Because that's one level deeper. So yeah, there is like a general tendency already to put these things inside the root of config and not inside these nested fields. Yeah, so I think it's pretty fair to move the rest. Okay. By the way, how are you guys? Well, what have you done today? Or if it's morning, maybe, where you're from, then what are you planning on doing? Okay, so we should move key length probably, right? Because we already have value length, we have create and default, so we should probably do pubfn create key length. By the way, the reason why we do comp time self is so we can do self dot key length type. If we don't use comp time here, then we cannot do this, because it returns type and we need this code to run in comp time, which I didn't know like 4 days ago that this is how you actually do it. So yeah, I've learned something. Okay, I think I should check out how I actually do that. Actually, how do we do that here? So create value length, and we call create length on the value. Yeah, we should probably even like move this up, probably. Yeah, I'm thinking like what are gonna be the rules that we follow when it comes to like what comes inside the nested fields? Like, is it literally just the default fields? Or is it maybe other functions, right? These functions, we could say it's basically a virtual field, right? That's we also use underscore. Why it's not this? Because that would be like a normal function, like a proper function. But we don't want that. We want it to look like a value, kind of like a lazy value. Yeah. So I think maybe these like virtual values should be here. I think that's okay. But probably assert size and all of these types should live somewhere else. Or there's another way to do this, and that is because this config is already big, right? I said that. And it's gonna just grow. It's gonna grow bigger. And if we keep moving stuff from the nested structures all the way here, it's gonna be even bigger. So I'm thinking that the main problem right now is that the functions inside of these, so for example, here in the data, these functions, they just see the self, which is in this case data, right? They don't see the config. So maybe what I could do instead is to have these only as like data, right? So for example, when it comes to size, right, this is data only. We have only min size, max size. We don't have any methods, nothing. And then somewhere here in the config, we would kind of like create something like const, or probably pub const, like uppercase count, maybe something like that. And we would say, okay, like create count with this config, or actually with self, which I actually don't know if I can do. I probably cannot do this, right? Yeah, I think that's gonna be the main roadblock in doing this, because I cannot use self in this way, I think. Okay, wait, let me just try something. Because this is the part of Zig that I don't really know. I'm just assuming, right? But like theoretically, if we want to, for example, create count double, right? Theoretically, we could do self count times 2, right? But yeah, it says undeclared. Oh, because self is, yeah, we cannot do this. Yeah, we cannot do this. Yeah, that makes a lot of sense. So what is our other option? So theoretically, we could maybe pass self as any type into the nested methods. That could also work, right? And by the way, I don't think that, like, no matter what option we choose, that it's gonna change how the code works, right? It's not gonna change that. It's just gonna change where we find stuff. And now the problem is that, for example, when we want to access anything regarding values, right? So here we have key and value. So if we want to do something with key or value, right? Let's say value. Where do we do it? Well, we have some methods for keys and values here in record, right? Like get value length or compare, or we don't actually, oh yeah, compare value or get value. We have this on the record, which kind of makes sense, right? You have a record, the record has a value, you would like to get the value of the value, right? Or get the value of the key. So it like kind of makes sense, and that's why I made it this way. But then you have the same thing in the root, or you can also find value methods in the root of config, like create value length, default value length, you know? And you can also probably find the type here, right? We have like TTL, temperature, and somewhere here we have data type, length type, and here we have value length type. So like it kind of makes sense to put it here, but at the same time, it could be in record, right? It could be. And then we also have stuff for getting data or types out of either key or value inside the data struct itself, right? So we have min size, max size, diff size, but then we also have assert size. We have all of these different types. We have create value, which we've already seen, by the way. We've seen create value and default value inside, and I'm not even sure where. Yeah, and that's the problem, right? Create value. Yeah, we've seen it in the config root, right? There's create value length. Even though the data, I mean this data, right? A data struct, but the field value, it has a method create length, right? So like, which one do I use? Like, both of them could be, or apparently are different, but like, it's not apparent in what way, right? I could change the naming a little bit, but like, what do I change it to? Right? Again, the distinction between these two is just, this is more like low level, or I don't know, it's less abstraction, and this is a little bit more abstraction, you know? But both of them, at the end of the day, create value length. Yeah. So this is the goal, right? To get rid of this confusion. Okay, I think I've talked enough. Now I should actually do something, which is actually the hard part, which is why I was talking so much, because I don't want to do this. Because it already works, but whenever I need to do anything on top of this code, I just end up being confused, right? That's the main problem. Yeah, so I think that maybe we should keep config as config, right? Just data, nothing else, just data. And maybe we pass config into something. So, which is the same thing we do, for example, here for record and random, right? We pass config into some other function, comp time function that returns struct. And the struct, in a way, or at least partly, is an abstraction on top of config, you know, because it uses some information from the config. Now, we could do this, although there is one slight problem, and I actually don't know if it's gonna be a problem, and that is, what if both record and random, and in this case also hash map, need the same kind of information, right? So for example, we do use, for example, here in put, we do config.hashtype and config.ttl input type, right? Those are right now on config. So now they would have to be somewhere else. Yeah. So maybe what we do is, even before passing, even before creating hash map, right? So for example, here in a test, we can see here that we create the hash map. So even before that, right? So somewhere between creating config and creating hash map, what we would do is create something else, right? So maybe controller, right? I don't know what to call it, but we would say like, okay, create controller based on the config, and then now instead of passing config into hash map, we're actually gonna pass the controller, which also has the config inside of itself, right? So we can still access the raw types or whatever if we need to. But also now, on top of all of that, we're gonna have these controllers or other like abstractions, you know, and it has a potential of being better organized, right? And I'm not saying it is going to be like just naturally be better organized, maybe not, but at least it has the potential to be. Yeah. So far this is the best strategy for making this into something more maintainable. Yeah. Right now, I don't really see any downside to this. Because like I said, in the controller, you could still probably access the config, right? There is no reason why you wouldn't be able to do that. So that shouldn't be a problem. Yeah. And then inside record, we would literally have only the methods that need record, right? So for example, if we look at is empty, right? That's a very good example. Empty is literally a field on or inside the record. So we do need to have an access to the record itself to do that. Just like compare hash, again, we need that, right? Again, compare key, the same story. Yeah. Getting the key, the same thing. getting a key length. Yeah, okay. Yeah, I think this is still gonna be a little bit confusing when it comes to key length, because it is either this max size, we don't have to care about like what this is, but it's either this comp time thing or it's this runtime thing, which is the key length itself, right? Because if the minimum and maximum size of key is the same, which means, for example, it's 8, we don't need the key length because it would always equal to 8. So that would be just weighted bits, right? Yeah, okay. So I think it's okay that there is still going to be a little bit of confusion, but at least on the level of config, there's gonna be less confusion. It's gonna be easier to maintain. At least that's what I think. Okay, what do you guys think? Do you think creating the controller or whatever we want to call it is the best option we have? I'm thinking that maybe in the controller, for example, we could have a field which is going to be called types, and inside the types we would literally only have the types for the fields, right? So it wouldn't be here together with all the normal functions. It would be, you know, stashed away in a different part. Or maybe the answer to this is to simply restructure the config, right? Because I'm thinking, okay, types, cool. I'm gonna have types field, which is gonna be a struct inside the controller based on the config, right? And inside of here, I'm gonna have like empty type, hash type, key type. That's cool. But all of these are record field types. But nothing about this screams record, right? Like key type with self, which is config, doesn't really tell us that this is supposed to be the hash type inside record, right? Yeah. Okay, so actually I think maybe that's the answer, right? Because like strategy, right? Like if we want to be very pedantic, then strategy of what? Like where in the system? Like what kind of strategy are we talking about? Right? The same when it comes to petting, like petting of what? Like of the, I don't know, values that we get from the input buffer, or like what kind of petting, right? If this was inside of another struct, which is called record, then we know, oh, so it's a padding of the record, right? Again, a count of what exactly? Yeah, I think if we actually structure this more, meaning we have more levels inside the config, which arguably is gonna make the config a little bit harder and more verbose to type out or specify in like a JSON or whatever. I don't know. I right now I don't know actually how we're gonna what was gonna be the recommended way for users to actually compile their own binary. Right now, actually, I'm thinking maybe there's gonna be some CLI, which is gonna have a cache of, uh, which is gonna have a cache inside of which there are versions of Entrica, and then you have a JSON somewhere in a folder. And if in that folder or directory, sorry, you call this CLI with any given version, actually what's gonna happen is it's gonna copy over the JSON inside the directory of that version, and it's gonna call zig build inside of that version. And inside the build script, meaning actually inside of here, because this is still a zig code, right? So we can read from the file system, we can decode the JSON, and then create the config instance here, right? So then we're just gonna pass the config. So I think something like this is gonna be the way, because I don't think it's very ergonomic for users to actually like git clone, go inside probably main.zig, find the config and change the config inside the code, and then build the thing. I think that's not very ergonomic, not a very good developer experience. So I think a CLI with some kind of a cache of those cloned versions of the repo is probably gonna be better. Yeah, but that's for the future, right? Right now, that's none of our concern how users are actually gonna use this, because right now there are no users except for me. Yeah. Okie dokie. So that means we're gonna have to create config 2.0 kind of. Yeah, we're gonna have to seriously rethink the config. Actually, you know, I knew this is gonna come, but I thought maybe we're gonna give it some better shape at the end, right? Because at the end of the day, it's just a shape, because that's my JavaScript brain, right? It's just gonna be JSON. Like, it doesn't really matter like what the things are called and if they're in the same on the same level or if they're like nested. But actually, the JSON directly translates, or probably is going to directly translate into a struct with fields that are themselves structs that can have methods. And I didn't really think about that. Yeah, but now when I do, I actually feel kind of stupid that I didn't think about that. Okay, whatever. So let's call this config2, just for the reference. After I'm done, I'm gonna delete it, but I just want to have this here so I can just quickly see how the code looked before, right? So now let's start basically from scratch, right? Okay, so I guess what we need first is record, right? We're gonna have record, which means that here we still need config directory, and here we're gonna create record.zig. Yeah. Which is also kind of telling me that maybe when it comes to hash map, it should also be in its own directory, right? Probably there's gonna be like config directory and cache directory. Yeah, maybe. And then like a server directory. And in the main, it's just gonna be like, hey, start server with this allocator, with this config, and push it inside the cache, right? Something like that. So it's basically gonna be like, what, 5, 6 lines of code? Like that would be the ideal state, right? Okay, so let's do that. Let's do that. And we also want server, right? So now at least hash map and record can live. Oh, okay. I have to do it like this. They can live here. So record also goes here. Obviously, we need files here to re-export everything. And we need main. I totally forgot about main. So let me just sketch out, you know, how it's probably gonna look like. Oh, and we also need allocator. And I know we're gonna have a custom allocator. You don't have to create the config because that's the only thing, or it's the only struct that's not comp time, right? Because all the other structs are comp time based on the config. So here we just need the config itself. But then we're gonna have a custom allocator based on the config. We have the custom cache based on the config. And then we're gonna have a custom server based on the config. So what we're gonna do, actually, so if we build, okay, I actually think we're gonna pass the config into the main function from the build function, right? So actually we're not gonna be like creating config here. What we're gonna do, probably, or actually, we just need the server, right? And the server creates the cache, and the cache creates the allocator. Yeah, so it's gonna be like a cascading effect, kind of. Okay, so actually what we're gonna do is, this is a type server, right? So we create server with the config. Now we say, I want to actually initialize the server, right? So we say init, and then we just say server. Oh, actually, this is probably gonna be var. Okay, but whatever. And then we're just gonna say probably accept, right? Or start. Maybe start is better. Yeah. And like that's it, right? So we just create the server type, we create server like instance, and then we do this, and we do defer server dinit just to make sure. Yeah, and actually I was thinking as a part of the dinit, which means if we like gracefully shut down the application, we could actually, and actually I don't know if the dinit gets called if we like do Control C in terminal. I actually don't know. Yeah, but in an event of a graceful shutdown, it would be good if we just saved everything we have in RAM on the disk, and then when we start the server, we try to read from disk, right? So we could have some very primitive and probably good enough persistency. Which means if you just, for whatever reason, shut down the server, you don't change anything, you don't recompile, you don't change config, you don't change the version of Entroka, you don't change anything. You just for whatever reason restart. Maybe you just updated packages inside the Linux machine, right? That's a pretty good reason. So in that case, you haven't changed anything, and it would kind of, be a pity if you lost all the already saved data, right? Because literally nothing changed. So yeah, probably we're gonna do that. Okay. So I just wanted to sketch out like how the main function is probably gonna look, which is like super simple, which is the goal, right? We want, or at least I want, I don't know how about you, and actually probably some developers don't have a problem with this, because if you, not GitHub, if you look at the Zig itself, right? If you go into, wait, is it in source or is it in lib? Okay, if we try to search for like allocator, simple allocator, so it's lib standard. Okay, yeah. So if you look here, okay, this is just 200 lines of code, but I remember seeing some pretty big files around here. So probably not in an allocator, but sometimes there are pretty big files, and probably the authors don't really mind, right? But my mind is sometimes pretty hard to manage, and so I need a very focused code, right? I just basically anything that doesn't fit on my screen is already kind of too much, and it's probably just like me problem. But it is what it is, right? I cannot finish this project if every file is like 500 lines of code. I just can't. It's just it's just impossible. I know this, I'm pretty sure. Okay, whatever. So we're gonna have record. Now let's go into the record. Oh, that's not the record. Yeah, okay. So inside the record, here we can actually have the count. We can have stuff like key, right? Value. I'm just gonna abbreviate it to temp, because it's just annoying to always write temperature, and I always almost mistype. I always make a typo. It's just so annoying. So we need key, value, data. I'm still on a verge when it comes to total length. Yeah, I'm still not sure, because I wanted to have total length so I don't have to do key length plus value length to get the total length. It would just be stored there. So theoretically, I would like save one memory load and one addition. But I think it's just, I mean, the whole reason why I'm making this library is because I want something super fast. So like over optimizing is kind of in its blood, right? But I think even for this project, including total length, just so we don't have to do one very simple and like local memory load and addition is just kind of maybe too much. Yeah, I don't know, but I just feel it's maybe a little bit too much. So actually, because in the past 2 or 3 days, working with and around total and a value length has been a pain in the ass, honestly. So maybe at least for the first prototype, let's not use total length. Yeah, let's not do that. Okay, cool. Okay, we still want the padding, right? Yeah, I'm pretty sure that even in the final release version, we will want users to be able to say, I either want more performance, right? I want to squeeze out as much performance as possible, which means everything is perfectly aligned, everything is very nice. We use full bits, right? Or I want to store as many records in this chunk of memory as possible, right? Which optimizes for memory. And obviously it has some cost, right? Right now we don't know what kind of cost. Yeah. Also, now I'm thinking maybe here in record we should just specify the things that kind of live in record, right? Because when it comes to the count of records, that's not something that the record is interested in. The hash map or the cache is interested in that, right? So probably shouldn't be here actually. Okay, then we had a strategy. Yeah, this could probably use a better name because actually it's eviction strategy. Or, well, in our system, what this is that we want the items with smaller temperature to be more likely to be evicted, right? So that's why we have the Boltzmann curve. Yeah, okay, I think I kind of went ahead of myself with this one, so let's just not include any config for strategy or for whatever we want to call it. Let's just hard code Boltzmann because I mean the whole idea of this cache is based on temperature and the Boltzmann constant and like thermodynamics and stuff, so I think that makes sense. Okay, we need temperature. Well, features. We could skip in the version before, right? We could skip assertions. Again, that's like saving a few memory loads in comparisons. Again, maybe this is just over optimization and no total length where we just got rid of total length. So again, we're simplifying a little bit. So yeah, let's get rid of that. I feel like when you develop anything, as a programmer, it's kind of, if you wanted to visualize the process, it's kind of like breathing, especially like before you hit the version 1, right? Because like you start with something, right? It like works, it's okay, but then you want to add more features, more configuration, more optimization. So it kind of grows, right? But then it's kind of starts being chaotic. So then you clean up the code, you get rid of maybe features that you actually didn't need or some messy code, right? So again, it shrinks. But then again, you want to add, but then it shrinks, right? So it just kind of keeps breathing, right? So in a sense, right now we are breathing out, right? Making it smaller. I just really like to visualize stuff, by the way. Oh yeah, and TTL. Yeah, we also need TTL. So that's TTL. Yeah, and I think this is also cool because in this way right now we can further create more directories, which directly translates into structs with methods that we can put inside of them or onto them. I don't know. Right? So if we just create a record here, now we can just, add the stuff that we need. So we're gonna have TTL, right? We're gonna have, oh, and I also forgot hash. It's a very important thing actually. So hash is gonna be something. Yeah. Let's just put this at the end. It's not very important. Well, key and key length. Okay, temperature. Okay, let's at least do temperature. Let's do just temp, actually. I think it's still okay to do key and value as the same thing because both are data, right? It's some kind of data. But then what do we call data? Yeah, data is just gonna be a pointer, actually. Yeah, and actually we don't need data here, right? We just need hash, so we know the hash type. We don't need these because this is just a config. It doesn't have to reflect the record itself. Yeah, so actually now we can use data. Now it actually makes sense, right? We have padding. Yup. I was just thinking, do I want padding to be in the very, very first version? I think I do. Yeah, okay. I already did the work with padding, so it's okay. It's okay. Yeah, and we also need hash. Okay, so again, we can just do a bunch of imports now. So let's do that. Yeah, by the way, all of this cleaning up of this code is probably gonna take a few streams, probably like 12 hours. Because there's already quite a lot of complexity hidden here. And now I kind of have to like dissect it and put it back together in a more shiny way, in a nicer way. But it's pretty crucial to do this so we can, or at least I can, continue developing this thing and not get mad, both in the meaning of being crazy and being angry. TTL padding found. What? Yes, okay. So now we do hash, we do data, we do data, we do temp, we do TTL, we do padding. Right? Pretty sweet. Now we can go to data, right? Because data is gonna have size. So we need a size. Yeah. Actually, now I don't know why there's data here. Shouldn't be here. Okay, let's do data directory. And here we're gonna have okay, let's not do it too much. I think we can just put the size inside of here because we're not gonna use it anywhere else. I was just thinking because here we need an extra struct, but we're not gonna use it anywhere else. So let's just put it here. So let's call it size, right? That's a struct of something. And then this is just min size, which is size, and max size, which is size. Yeah. No, let's do it. You know, like if I do it everywhere except for one place, it's a little bit confusing. So let's just do this. Yeah, I think this is pretty nice. Yeah, so we're gonna have data, hash, padding, temp, and TTL. And all of that is inside record. Now, another thing we're gonna have here is cache, right? So inside cache, we're actually gonna have the count. And I'm actually thinking, you might either want to specify how many items you want, right? So you want to have, I don't know, 65,000 items, or, and I think in most cases probably, what you want to specify is the maximum memory, right? At least that's how Redis and memcached works. So if you go to memcached, right? Like, I don't know, setup, something like that. Yeah, if you want to just install it and start it, there's probably gonna be some setting for maximum size or something. Maybe not. I don't know. I just remember there is config, yeah. Memcached conf. Yeah, here. Literally just M as in memory. Yeah, so you just specify you want up to 64 megabytes of memory. So we probably want something very similar, but we still want to let users specify the exact size in like number of records they want, right? So probably what we're gonna have here is also size. It's gonna be a different size, right? So later when we actually like create the config, we're gonna have size, which equals to, and now we're gonna have probably an enum, right? So it's gonna be either like count, which is probably just gonna be a number, or yeah, I actually don't want it to be number because I want to have methods on it. Yeah, so I don't know, number is like 1024, right? Or I want it to be like memory, which is, and again, I would just call it like number, and now you would just specify how many bytes or whatever. Yeah, but for now, let's just keep count, you know, just to make it simple. Okay, so we're gonna have cache record. Now I'm thinking, should allocator be created or configured, not created necessarily, but configured underneath cache? Well, like technically speaking, everything except for server is underneath cache, right? Yeah, don't know. And you could even argue that actually everything is underneath server, right? We have server, underneath server is the cache, inside of which is allocator and record, like on the same level, kind of. Yeah, but I don't quite see, at least not right now, a reason why I should actually reflect this in the config. Yeah. Cache. Allocator. And this is record. Don't quite understand the error here. Kind of weird. Declare between fields. Yeah, don't know why it's telling me this error. Whatever. So here we probably want a port, right? That's an easy one. We probably want to specify how many threads. Although I'm thinking, is there any reason why I would want a different number of threads? Well, I could be running the cache together with some other service, maybe on the same server, even though it's not recommended. We should still probably allow it, right? So threads is still a number. Yeah, I don't know what else we should have here. Yeah, we have a count here. And actually right now, I don't know how the allocator is gonna look, so this is just gonna be empty. Yeah. I just want to see how it's actually gonna look. Maybe in the allocator we could say huge pages. Is it what it's called? I don't know if it's like big pages, huge pages, large pages. Allocator huge pages. Huge pages. Huge pages. Yeah, I think it's just called huge pages. Yeah, at least we're not at least I am not the same, not the only one who says this. I don't know why I wanted to say same so bad. That doesn't make any sense. Oh yeah, so huge pages is gonna be true. Actually, wait, I think, oh yeah, I made this huge size. No, should be bool. So huge pages. Now obviously record. Let me just get this. So this is gonna be hash. Type is U64. Key equals static. Min size 1, max size, let's say 8. Now let's do value. That's gonna be dynamic. Actually, maybe let's do, wait, 250. Okay, let's do 250. Yeah, if I remember correctly, memcached max key length is 250. Yeah, it's 250. So let's keep it 250. Let's try to just replicate the default memcache settings. Memcached, this is one default value length. Yeah, but this is the custom one from Google. One megabyte. It's just 1 megabyte. The minimum is 512 and the maximum value is 128. Oh, the maximum and the default value is 1. Okay, so 1 megabyte. So min size, oh, they said 512 kilobytes. I think that's pretty weird. That minimum is 512. No, let's just keep it 1. And let's do max size, or okay, let's do 256. Okay, and 2024 bytes. So 24 bytes to kilobits is 1 kilobit. So when we want 1 megabit to bytes is this. Okay, and 256 bytes to kilobits. Okay, let's make this 1024, so it's 1 kilobit. Yeah, whatever. Okay, so that's value. Then we have temperature. So temperature is gonna be type, which is U8, and the warming rate, or whatever we called it before. What was it called? Temperature. Yeah, we called it rate. Okay, so let's still call it rate, which is 0.05. Let's do 5. So 5% chance that it's gonna increase the temperature. Yeah, then we have TTL. Here I'm still not sure, but I think let's do units equals seconds, or second and its unit. So 1 unit is 1 second. Yeah, and now min input size equals u size. Actually, sorry, max. Could we also specify the minimal TTL that everything has to have? It kind of makes sense, right? Maybe there would be some use cases where you just want to force everyone to use TTL. Yeah, actually, I didn't think about that. Okay, min input size, and let's call it max total size, which is also u size, right? And actually, I said that we can have absolute, relative, or none. So I think we can do relative, which is probably what I would go for, because it saves a few bits here and there. So we would do relative seconds. Let's say we want at least 1 second TTL. No, let's do like 1 minute. Although if it's minute, why not change this, right? So let's do at least 10 seconds. No, at least 5 seconds. No, okay, let's just make it 1 second. And then 2 to the power of 16 seconds in days. Okay. I guess that's all right. Let's do this number. And then it's from the start of the server, right? That's relative. Actually, there should be reference, right? And that should be standard time. What is it called? Fuck, what is it called? Timestamp. And actually we can make this default to this value. So we don't need to, yeah, let's just comment it out just to know that it's there, hidden, but it's still there. So minimum 1 second, maximum input is this many seconds, and let's make it 2 to the power of, I don't know, 24 seconds to days. Okay, let's make it 1 year at least. Yeah, okay, so 2 to the power of 25. So this is our maximum. So theoretically, after 1 year, you would have to restart the server. But I think it's fair to assume that you are going to restart it at least once a year, which means you don't have to store more than 1 year worth of TTL. Okay, and then we're gonna have padding, and let's say I'm optimizing mainly for performance. So I want both internal and external padding. Okay. Now, okay, theoretically, if I want to support both count-based and size-based, how would I do that? I need size, right? And then I would say the size is, we cannot have like enum with a value, right? I don't think that's possible. So I have to wrap it, and then I have to say, okay, this is gonna be a type. No, this is gonna be, yeah, I actually don't know how to call it. Something like a count and memory or something like that. So let's say memory. And I guess now we can just provide the size, right? So it's the size and the memory is, okay, let's do, default size. Well, that's 1 MB. Okay, I don't know. Let's make it 4 gigabits in bytes. Right? So this is gonna take 4, well, no, we're gonna have 4 threads. So let's say each thread is gonna consume 1 gigabit of memory. Together, obviously 4 gigabits plus some overhead. Yeah. And allocator right now we don't know, right? It's just huge pages. Maybe if it's either slab allocator or body allocator, or I already have a prototype of a like a multi-layer bitmap allocator. In all of those cases, we would need something like a chunk size. And most likely we're gonna select one of those. So most likely we're gonna have a chunk size. Right, so one chunk, wait, we have memory here. Yeah, it kind of overlaps with this. I guess we would have to have like a compile time check that the min size here is at least the chunk size. Well, I mean, theoretically we could allow other values. Yeah, we could. We could, yeah. Okay, whatever. Okay, so chunk size, we set the min size for dynamic, well, it's min size of dynamic allocation, right? It's min size of dynamic allocation. Well, the min size basically is the chunk size. Yeah, not sure. Because these two really do overlap, right? The dynamic key or value and their min size kind of overlap with the chunk size. So probably the chunk size will be derived from key and value min size, right? If both are dynamic, then we do min size of key plus min size of value, and we get the chunk size, basically, right? And we should also round it up to the closest 8 or whatever, just for better alignment. Yeah, okay, not sure. Yeah, and I'm not sure because we don't have a concrete implementation of an allocator, so it's kind of hard to think that far into the future. Okay, so I think this is kind of, except for the allocator, how the first version's config could look like. I'm thinking, is there anything else we want to do inside of the cache? I mean, we want to config inside of the cache, not sure. Because really, inside of the cache, which I renamed into hash map, theoretically the random numbers, because right now they take the count as how big they should be, as the input for how big they should be. Theoretically, they could take something else. So I could just increase them, giving me like on average more random values. But don't know if that's needed or if it would have a significant impact. Yeah, don't think so. And here all we do is we just create X records, right? We allocate for X records and then we just work with that. So I'm not really sure if there's anything else to config, honestly. Probably not, probably not. Oh, but we should be able to modify this. The curve constant. Yeah. And that is inside record. Yeah. Wait, let me see. Cache record. Yeah, we get the curve here, and then we use it for getting is unlucky. So if the random temperature is bigger than the value we get when we index into the curve. Yeah, so it's very like it's very record like. Okay, so it should be inside record. So let's say curve. I actually don't know what to call it. Constant is 32.0. Yeah, so I just guess this is what we would call it. Yeah, maybe we're gonna figure out a better name, but for now, let's just call it curve. Okay, this config is much cleaner. I think based on this, we can simplify the code quite a lot, actually. Yeah. Okay, yeah, that's cool. Yeah, I'm actually gonna implement it next time. I think right now we've already used quite a lot of time, spent quite a lot of time just figuring this out. And here, yeah, it's almost 7. Yeah, so I think I'm gonna go. But I actually like this new config. It makes more sense. And it's gonna give us better structure. Yeah. Okay, I guess that's it. Do you guys have any questions or suggestions or anything? Offensive name and spammy. Wow. By the way, I want to release like a very alpha or prototype version as fast as possible. Although right now I'm trying to figure out the licensing because I don't want it to be fully like MIT license, right? Like do anything you want with it, because kind of the ultimate goal is to build a SaaS, a service around this, and potentially multiple different services using this cache. So I want the license to be basically like you can do anything you want with it except for building a SaaS or like selling it basically, or creating a product that you sell whose main value is based on this library. Or you cannot fork it and do like minimal changes and then again make profit. Something like that. But I don't know, maybe I'm just overthinking it and I should just use MIT. I don't know. Yeah, but right now the repo is private. Okay, so no questions, no suggestions. I guess that's it. So thank you guys for being here today. It was very quiet here, but at least I could think, and I think we got some good result. Yeah. So yeah, thanks again, and see you